In this video, we are going to solve simultaneous equations which involves three equations and three variables. Now, in the solution, first of all, we have to write down what is given. So, they have given the system of simultaneous equations consisting of three equations. Now, the next step is to rewrite the system of simultaneous equations in matrix form. So remember, this is the matrix for the coefficient. Let us write down the coefficients. 4, 1, minus 5. You must be very careful with the negative sign attached with the coefficient. Next row, minus 2, 3, 1. Next row, 3, then minus 1. You must remember, if nothing is there in front of a variable, just like in this case and in this case as well, then the coefficient is 1. 1 times, let us check for this one, minus x2. So this will be minus 1 times x2 minus into plus is minus 1 times x2 is equal to x2. So the coefficient is minus 1. Similarly for the others as well. The last one is 4. What are the variables? The variables are x1, x2 and x3. Now this vector out here is the constant term vector. So we have 8, 12 and 5. Let us name the coefficient matrix by A, the variable vector by X and the constant term vector by D. Now the formula for finding the solutions of a system of simultaneous equations by matrix inversion is X is equal to A inverse times D. X is the variable vector, A is the coefficient matrix, we have to find its inverse, times the constant term vector. Before proceeding further, we need to find first A inverse. Now we have already solved problems based on A inverse, that is finding the inverse of a given matrix. There are two conditions. The first condition is that it should be a square matrix. So the coefficient matrix out here is a square matrix of 3 by 3 order. The second condition is that the determinant should not be equal to 0. Let us proceed and check whether its determinant is equal to 0 or not. The determinant of a given matrix is found by taking the sum of the minors of the elements present in the first row of a matrix in case of a 3 by 3 order. And also we need to take care of the positional sign of the elements. Now element 4 is present in the first row and first column. 1 plus 1 is equal to 2. It is an even number, so we have plus sign out here, 4. Now deleting the row and the column in which element 4 is present, we are left with 3, 1, minus 1, 4. Next element 1. What about its positional sign? Element 1 is present in the first row and first column. First row and second column. 1 plus 2 is equal to 3. 3 is an odd number, so we have minus 1. After deleting the row and the column in which the element is present, we are left with minus 2, 1, 3, 4. Next element minus 5. Minus 5 is present in the first row and third column. 1 plus 3 is equal to 4. 4 is an even number, we have plus. But the element is minus 5, so let us write this element within bracket minus 5 since it is a negative number. Now deleting the row and the column in which element 5 is present, element minus 5, we are left with minus 2, 3, 3, minus 1. Now this is a second order determinant. So how do we find out? We cross multiply 3 times 4. Remember there's a minus sign in between, and minus 1 times 1. Let us do it. 3 times 4 equal 12, minus in between, minus times plus is minus, let us keep that within bracket. 1 times 1 is 1, minus 1, minus times plus is minus, 2 times 4 is 8, minus 3 times 1 is 3, plus into minus is minus 5, minus times minus is plus, 2 times 1 is 2, minus in between, 3 times 3 is 9, 4, 12, minus times minus is plus, 1, minus 1, minus 8 minus 3 equal minus 11, minus 5, 2 minus 9 equal minus 7, 4, 12 plus 1 equal 13, minus minus times minus equal plus, 1 times 11 is 11, minus times minus is plus, 5 times 7 is 35, 4 times 13 equal 52, plus 11 plus 35. Now this will give us 98. Now we have to write, since the value of determinant A is not equal to 0, therefore matrix A is non-singular and A inverse exists. I hope you still remember the steps involved in finding the inverse of a matrix. The first step is finding the determinant of the given matrix, which we have completed. The second step involves finding the cofactor of each element of the given matrix and arranging the cofactors in a matrix which is known as the cofactor matrix. Before proceeding, let me copy this coefficient matrix somewhere here so that it will be easy for me to refer. Now cofactor of A11, which is the element present in the first row and first column, which is 4. What about its positional sign? 1 plus 1 is equal to 2. 2 is an even number, so we have plus sign. Deleting the row and the element, deleting the row and the column in which the element is present, we are left with 3, 1, minus 1, 4. Let us simplify. 3 times 4, 12, minus in between. Now minus times plus is minus. Let me write within bracket minus. 1 times 1 is 1. Let us simplify further. 12 minus times minus is plus 1. 12 plus 1 equal 13. Next, cofactor of A12, that is element present in the first row and second column, which is 1. What about its positional sign? 1 plus 2 equal 3. 3 is an odd number, so we have negative. After deleting the row and the column in which the element is present, we are left with minus 2, 1, 3, 4. We have negative sign outside the second order determinant, so we need to keep it outside the bracket. Minus times plus is minus. 2 times 4, 8. Minus in between. 3 times 1, 3. There's a minus sign outside the bracket. We need to take care of it. Minus 8 minus 3 equal minus 11. Minus times minus equal plus, so we have positive 11. So in this manner, the cofactor of all the elements in this matrix is found. Next, cofactor of A32, that is element present in the third row and second column, which is minus 1. What about its positional sign? 3 plus 2 is equal to 5. 5 is an odd number, so we have minus. After deleting the row and the column in which the element is present, we are left with 4, minus 5, minus 2, 1. Minus should remain outside the bracket. We must be very careful about it. 4 times 1 is 4. Minus 2 times 5 is minus times minus is plus. but there's a negative sign in the middle. So 2 times 5 equal 10, minus 4 minus 10 equal minus 6. So we have plus 6. Next, cofactor of A33, element present in the third row and third column, that is 4. What about its positional sign? 3 plus 3 equals 6. 6 is an even number, so we have plus. After deleting the row and the column in which the element is present, we are left with 4, 1, minus 2, 3. 4 times 3 equal 12, minus times plus is minus. 2 times 1 is 2. 12 minus times minus equal plus 2, which is equal to 14. So let us list all the cofactors of each element in the cofactor matrix, starting from A11. So cofactor of A11 is 13. Now let us list all the cofactors of each element in the cofactor matrix. Cofactor of A11 is 13. Next, cofactor of A12 is 11. Cofactor of A13 is minus 7. Cofactor of A21 is 1. Cofactor of A22 is 31. Cofactor of A23 is 7. Cofactor of A31 16. Cofactor of A32 6. Cofactor of A33 14. So this is a cofactor matrix. The third step is that we need to find the adjoint matrix of A, that is adjoint A. Adjoint of a matrix is nothing but the transpose of the cofactor matrix. That is, we need to interchange the rows into columns or columns into rows. So let us interchange the rows into columns. Now we have completed the third step. The final step involves substituting the determinant in the given formula for A inverse and also the adjoint matrix A. So the determinant which we got is 98. So let us write 98, 1 by 98 times adjoint matrix. This is the adjoint matrix. So this is our A inverse. Next, we need to substitute A inverse which we have found in the formula of matrix inversion. Now remember, we are not going to simplify A inverse here. We are going to leave as it is, so that will be easy for us in later part. I mean in the simplification process. So we'll substitute A inverse in the formula with D, which is the constant terms vector, Let us simplify further. In the simplification process, we'll leave this fraction out here, 1 by 98 as this, and we are going to multiply this matrix with this vector. Now we know the rule of multiplication and the multiplication process. Let us start with the first row. 13 times 8 plus 1 times 12 plus 16 times 5. Next, the second row, 11 times 8 plus 31 times 12 plus 6 times 5. The third row, minus 7 times 8 plus 7 times 12 plus 14 times 5. Let us simplify. 13 times 8 equal 104 plus 1 times 12 is 12 plus 16 times 5 equal 80. For the second row, 88 plus 31 times 12 equal 372 plus 6 times 5 equal 30. The last row, minus times plus is minus. 7 times 8 equal 56 plus 7 times 12 equal 84 plus 14 times 5 equal 70. Now let us take the sum of each row. 104 plus 12 plus 80 equal 196. 88 plus 372 plus 30 equal 490. Next, minus 56 plus 84 plus 70 equal 98. You can use your calculator so that you will complete it faster. Now I'm going to multiply this fraction with each element inside this vector. Let us cancel wherever possible. 98 times 1 equal 98. 98 times 2 equal 196. 98 times 1 equal 98. 98 times 5 equal 490. 98 times 1 98. 98 times 1 98. So we will have 2 divided by 1, we will get 2. 5 divided by 1, we will get 5. And 1 divided by 1, we will get 1. So finally we'll write down x1 is equal to 2, x2 is equal to 5, and x3 equal to 1. Now if we substitute the values of all these variables in either of the equations given in the problem, we will get, or we will satisfy the conditions where the left hand side is equal to the right hand side.